Good day, ladies and gents. Welcome to BK Mathematics, and this is the continuation of differentiation on first principle. We started it. Let's try to look at this problem that we are given also. It reads: obtain from the first principle the derivative of f of x is equals with x. Now, to start with, we have that's a solution. Okay. Now, to start with, we have our general formula that we are to use to differentiate. We say dy upon dx is equals f of x into x plus h minus f of x divided by the whole function. The limit, if the limit h tends to 0. Okay. Now from this point, what I have to do here is we just need to substitute now. But remember, this is the function that we are given. F of x is equals with x. So it means anywhere we see x here, we replace it by x plus h. Anywhere we see x here, we replace it by x plus h. Now we say from this, we say this is root x, and anywhere we see this, we replace by x plus h. We say root x plus h. This x we replace by x plus h minus, f of x. This is the whole function that we are given, which is root x. Then everything becomes h. Okay. Now from this point, what are you to do next here? You applied rationalization of sorts. Okay. Let's say by rationalization of sorts, by rationalization of sorts. Let's rationalize this one. Now rationalizing this one, we are just like this becomes root x plus h minus root x divided by h. Now multiplying by the same thing. Also, we rationalize the numerator. Most of you always know that most often we always rationalize denominator. Here in this case, we need to rationalize the numerator. That is this. Then this one becomes root x plus h plus root x, then divided by root x plus h plus root x. Now from this point, what I need to do, we multiply a corresponding term. This is multiplying this is also multiplying this. Okay. Now let us multiply and see what we are going to have. We say root x plus h multiplying by root x plus h plus root x. What remains is first bracket is minus root x. We use it also to multiply the second bracket, that is root x plus h plus root x. Then everything becomes, here also if we are multiplying, this one becomes h into root x plus h plus root x. It continues. Now if you are multiplying root x plus h multiplied by root x plus, they are the same, and the rule stated that if you are multiplying the same root, just take what is inside the square root. That is, we just need to take x plus h plus multiplying root x times root x plus h. This one giving you root x plus h into root x. Okay. The same thing minus the same thing implies this is root x plus h into root x minus multiplying the same root, we take what is inside, that is x square. You take what is inside, that is x. Okay. Now the next step, we maintain this one, that is h into root x plus h plus root x. It continues. Now we know this is cancelling this because this goes. Let's guess what remains. It is x plus h minus x divided by the denominator, that is h, into root x plus h plus root x. Then if you are subtracting x minus x, then we are going to have, this is minus plus h, that is h remains, because x minus x goes, it only remains h divided by h into root x plus h plus root x. The next step, h into itself one times into h one times. Then let's write also what remains. Let's say it continues from this point. Okay, now what remains is 1 divided by root x plus h, root x plus h plus root x. This is what remains. Let's know that we say but h tends to 0. It means the value of h that you are given, it is 0. From this we substitute now. Now we have 1 divided by root x plus, this is h and h is given as 0, plus root x. Okay, then we have, this becomes 1 divided by root x plus root x. Okay, then we see 1 divided by root x plus root x, giving you 2 root x. Okay, so this is what we are asked to differentiate in respect to the problem that we are given. This is, our answer then becomes 1 upon root x plus h. Thank you for watching. Make sure you share for others to benefit. Okay.